The funny thing as a globe believer is that you actually have to believe that gravity gets stronger as you move further and further away from the Earth. Because for some reason, gases will move upward and away from the Earth until they get to the thinnest, most region of space. And then suddenly, the gravitational effect holds those particles.
You don't have to have it be stronger gravity the more up you go for that effect to happen on a globe Earth.
It obviously does, because from the ground level, that gas particle moves upward. And then as it goes to a point where the gas is so thin and the gravity should be so weak, it suddenly ceases to move upward and is contained, not only contained, but
No,
starts to move back towards the Earth. So there
but
is
it
no
sounds
way
like you're
to
expecting.
reconcile
But
it.
it sounds like you're expect. Yeah, but it sounds like you're expecting the gravity to drop off so much that it would be like insignificant at the top of the atmosphere, though. That's what you're making it sound like. The gravity difference
False.
between that and the
False.
ground is not
You,
big.
it was your point. Your point was that the gravitational effect at the ground level will be stronger than it will be
Yeah,
away from the Earth. And I was
but it's
simply
almost
pointing out the
insignificant.
contradiction. Oh, so it's insignificant. So that's why
It's
at
almost
ground level,
insignificant.
so at ground level, where the gravity is strongest, the particle moves upward. And then
Yeah,
when
but
it
you have
reaches an
to.
altitude where the gravity is insignificantly weaker, it instantly ceases to move upward and starts to
But you have
return
to
back to the Earth.
understand. You're commenting on a model here that also includes keeping the moon in an orbit that is 10 Earth diameters away from itself as well, right? So that is also in the
It's
model
more.
that
I
it's
think it's about
keeping this very.
It's about
Hmm?
120 Earth diameters away. The moon.
I
Oh,
don't
you
think
said
that's true, but
Earth,
that's
Earth, Earth diameter. Sorry, I was thinking moon diameter.
yeah,
Sorry.
Earth diameters. Oh no, no, not moon diameters. So you're probably right on the moon diameters, but no, Earth diameters. And so we're in that's in this model. So I don't know where you would get it from that gravity would be so insignificant. Like if you were to take the thickness of the atmosphere on an apple Earth, it would be like the thickness of the peel of the apple. That would be still so close that the gravitational pull on the top of the atmosphere wouldn't. So just because it gets thinner and lighter doesn't and then you have this cutoff point. The only reason you have this cutoff point you speak is because that's when we don't have any more matter of air left. If the Earth would have been like injected by a huge syringe of way more air, then that top layer would have just been thinning out further out instead, right? The reason there's a cutoff point to begin with is because there's no more air.
No, but perhaps you're missing the entire point of what I was saying. Is that
Maybe.
at the surface level, it's said to be the strongest. And at the surface level, air particles move upward. And then when it gets to this, what you termed insignificantly weaker point, suddenly that air particle no longer wants to move upward and chooses to move
Okay.
downward. But the point
Yes.
is at the surface level, at ground level, where that gravitational
I
attraction
see. I
is,
see.
in my mind, a little bit stronger, it moves upward.
I understand what you mean. Okay, but I think the simple explanation here is the only reason the ones at the bottom move upward is because more dense ones are falling and replacing the ones at the bottom. So you have these invisible air particles dripping down because either they got colder, maybe you have wind as well, right? And then they're gonna and the hot air, if it's hotter at the ground, it's gonna obviously move up because it's gonna be displaced. But when it reaches the top, the ball game is like over. There's no more displacement needed. They can just lay there. It doesn't need to continue going upwards. It isn't going upwards to begin with due to the gravity at all. It's just being replaced by colder or more dense air particles falling down, replacing it, making it go up. And then it lays itself on the top, and then there you have it.
Perhaps, but you do understand that oxygen is produced at ground level. generally by trees and fauna or
Yeah, and
flora,
photosynthesis.
and then
You-
and then it moves upward. So it's not like there are heavier air particles being produced higher up
the-
that choose to descend. The air is produced
Well,
at ground level
because you have,
and
but
then
because you have constantly
proceeds
have
to move
cooling though.
upward, but then proceeds to move upward when the gravitational attraction should be the strongest, and ceases to move when the gravitational
But the
attraction is
gravitational,
slightly
it
weaker.
doesn't matter. It's like irrelevant in this equation though. Like it doesn't really matter if you have strong gravity or weak in the scenario. Even if you had the sun's gravity and you had Earth, like you would still have the air going up from the bottom, and the
Look, brother,
effect of the
you and I
gravity here
both,
doesn't really matter.
you and I will both definitely agree that gravity doesn't matter and that it's insignificant. Like I don't believe in it, so you don't need to convince me that it's insignificant and pointless.
I
But
understand that part. I understand that part. But what I was saying is, as long as you have any gravity on all
but
the
isn't that
particles, if the
peculiar?
gravity, what?
Don't you
Well,
find that peculiar that at ground level air particles move, and if you look at the speed that air particles move at, it's several hundred feet per second. It's not. It's not like half a foot
yeah, but
in a minute.
depends on the air
You know,
pressure though. If you have it very pressurized with one atmosphere, they're not going to be moving that fast. They're going to be bumping into each other, causing small like pressure ripples or whatever. You're not going to have it moving that fast if it's one atmosphere pressure.
one atmosphere, like in a containment. You
Yeah,
do
like
understand that
the normal
to
pressure.
have
Okay, okay.
pressure. So pressure is the pressing on a container. The definition of pressure, how do we measure pressure, is the pressure exerted on the walls of the container. So to have
Sure, but it's
one
also being
atmosphere
exerted in the
of
middle.
pressure, due to collisions, yes, and
Yeah, so
obstructions,
it's
but
everywhere in the
the
box, not
initial,
just the walls.
the but the definition of pressure, the definition, not mine, the definition of pressure is the pressure it exerts on the walls of the container. And generally, when we put
Yes.
in a pressure valve, it's on the wall or on the containment. So to have your one atmosphere of pressure, you have to have some kind of containment. Take that containment away. So imagine you've got a vacuum chamber adjacent to a really high pressure air system, and you remove the
Yeah.
wall that divides them. Do you believe
Yeah.
that they would equilibrate? Would they
So
equilibrate,
no,
or
no,
would they
no, because the
retain
Earth.
one container holding pressure and one container having a vacuum?
But you see, I think you understand that a vacuum doesn't suck, right? Air just moves where there's empty space to move. We agree with that, right?
Absolutely, absolutely. And would you consider a
Okay, good. So
vacuum?
if
Would
I
you consider a vacuum a space for air to move to?
yes, and so a pressurized system will always be inherently moving towards a vacuum because that's where it wants to go. And you talked about
Because it's a
air
space.
mole,
It's an available
and you
space.
talked about and you talked about air molecules ascending a little bit earlier ago, right? So essentially that going on. You have things going up all the time to because you want to reach the wall of the vacuum. The reason, and I know you don't believe in gravity, but the
The
reason doesn't.
wall of a vacuum.
Yes,
Hold on a sec.
but just
You
listen
said
to
a
me.
wall of a vacuum. What wall of a vacuum?
Yeah, I was imagining a box, like if you have a vacuum chamber, and if you have
Okay,
a
okay,
complete
got
vacuum and you remove the wall, or if you make a hole or remove the whole wall, air is going to come rushing in, but not because the vacuum sucks it, but because the air pressure pushes into the empty space, right?
you. It always
But if
moves
you
from high
imagine,
pressure to low pressure. 100%.
yes, now zoom out and you look at the whole ball Earth in the globe model. And now you see all this air sitting on this thing, and it's a limited amount of air, and it's always moving towards the edges of space. The reason it wouldn't just continue and find an equilibrium and mix in with space is because in this model you also have gravity making it stick to the ball Earth all the time. So you have a no charge, the vacuum, it's not a negative charge, and then you have the positive
But we
gravitational
both
force.
agreed, but we both
And do we,
agreed that
but wait,
at
wait, wait, just
surface
one second,
level,
just one last, just one,
where
yeah,
gravity is strongest, it doesn't contain that gas. And then at some undetermined level up in space where the gravity is so thin and the particle density is so thin, it suddenly chooses to hold on to that molecule that left the surface of the Earth and moved upwards. So it's easy to assert, yes, gravity holds it, but then gravity would hold it in the band right at surface level. It wouldn't allow it to move upward freely to some predetermined level and then
So wait, so you're saying it
suddenly
would be like
this,
1 millimeter thick, or what?
not that kind of a straw man, but it would be probably 1 kilometer thick if gravity were an actual thing holding air molecules. But
No,
air
because you
molecules
have
don't
to let
really
no,
have
because
mass.
density lowers.
So
No,
therefore,
but
mass attracting mass doesn't quite work.
Everything has mass.
okay, either you can disperse left to right or forward, right? And if you imagine a ball earth with gravity, that's not going to give you a changing pressure if you walk across that surface. But it's also going to have the possibility to sponge on itself up and down because the gas pressure is pushing on the gas itself. So you expect a lesser and lesser density the higher up you go. You also expect it to be colder the more up you go. And so then that will become colder air that then goes down, and you have like this almost cyclical wind motion up and down. And you would expect it to be less dense the further away you go. And yes, the reason you have stronger gravity at the bottom, you also have the biggest pressure at the bottom. That's why you have 1 atmosphere of pressure at sea level, because it's being sucked down all the time by the same force at all times. It doesn't vary. Gravity is measured at 9.82 meter per second squared. That's the constant acceleration of all matter. That's why we have a constant air pressure.
So convectional currents, we completely agree with. Density relationships, higher density and lower density causing movement, 100% agreement. In terms of your assertion that gravity is the cause of oxygen remaining on the Earth, while the Earth hurtles through space, not in a stationary model like what you said, that the oxygen is just sitting around the Earth while the Earth just kind of sits there in space. In that model, yeah, maybe I can kind of wrap my head around it. But with a spherical object hurtling at 66,000 miles per hour through this vacuum of space, the air is not velcroed to the surface, and therefore
But you would
it would
agree.
streak
Sorry.
out. There would be a tail in the same way that you'd see a comet having a tail. You would see a tail on the Earth of all the oxygen that's being left
No,
behind
I can
as
explain
this
why. Also, you
object moves through this vacuum of space, with gravity actually having no effect on the movement of the oxygen, because, like you just asserted, it's got to do with cold air and hot air and a convectional
but
current of hot air
hold
moving to
on. What
cold
was the speed
and
you said?
cold returning ground. But the idea of gravity holding an air molecule is ludicrous. And if you were honest, you would say, yes,
I can address that.
this is
Okay,
a bit of
what did
a
you? What was
puzzling
the
point.
speed? What was the speed you said? 66,000 what?
66,600. 66600 is the
Okay,
proposed speed of the Earth, not measured. It's never been measured that the Earth travels at that speed. In your model, that's what
but
it's asserted to be,
yeah, I was
based
just
on the
wondering.
size of the radius,
Do you?
the size of the radius around the sun divided by the number of days that it should be moving, and therefore we can calculate, not measure, calculate what the presupposed speed of the Earth should be through a vacuum, not measured. And therefore, if the
Yeah,
object
okay.
was moving through space at said speed, it would be leaving the oxygen behind.
Yes. Can I please address that now? You agree with me that the speed doesn't matter at all if you're going through a vacuum, right? You understand there wouldn't be a comet tail. Y- There's nothing pushing on you in a vacuum, so you wouldn't have a drag effect. Do you agree with that?
You agreed with me earlier that oxygen will, or any high pressure gas, will move into the available space. Should there not be a
Yes, but I'm
solid
saying movement
barrier
doesn't matter in a vacuum.
preventing them? So I'm not talking about moving through a vacuum, that the vacuum's imparting any kind of force or any kind of suction pressure or any of that straw
I
man
get
that
that.
you want to try and spin. What I'm
No, I
saying is
understand your
space
point.
is an available volume, and gas, especially high pressure gas, wants to fill the available volume. And with an object having presupposed gas encompassing it, and there is nothing attaching that gas physically to this earth, as you would agree, there's no physical barrier. Therefore, if the
No,
object
gravity
moves
does.
with that air, well, gravity doesn't hold it at surface level where gravity is supposedly strongest. So therefore, gravity doesn't
It
hold off.
does. Gravity does hold it to the surface.
Yeah.
For
Everything has a weight. So
gravity,
everything.
But
it's got to do with
exactly. So, but I
cold
gotta
air
address
sinking,
this vacuum thing.
cold air sinks, and hot air
I,
rises. You
yeah,
agreed to
yeah.
that. You didn't say that gravity is the reason that cold air sinks. You said cold air sinks because of convectional current. So therefore, you can't impose a fictitious pseudo force like gravity
Yeah,
for
but both
holding
both
Can I?
are
But can I
minuscule
just? I
gas
need to address thing.
particles
You never let me
at
address.
several
Just real quick. I
just
need to
a minute.
address the
Just one
comet
thousand
second.
point.
years away. Okay, so a comet also doesn't leave a tail, or because the comet's
Yeah. Can
moving
I
through the
explain the
vacuum,
comet?
or
Okay.
only the Earth
Explain the
wouldn't
comet.
leave a tail.
Yeah. We brought the comet up as an
You're more than
example
welcome
multiple
to.
times. Yeah. So we do see comets leaving trails. So that is an observable thing. We would all agree comets exist, right? And the reason that they leave trails is because that is usually water evaporating off. And then you say, well, why doesn't the water vapor just stick to the comet like the air would on Earth going through that speed in the universe? Because the comet is way smaller than a planet and it doesn't nearly as well hold the dispersion that is continuously going on. Like you said, the gas wants to disperse out, but the gravity isn't as strong as Earth, so it doesn't contain the whole atmosphere along with it. So it creates a trail, and then you have sunlight refraction going on all over
Gravity
that
is not a
vapor
containment,
trail. No, but what I'm saying is that's why you have a trail in a comet because it doesn't have as strong of a gravity. It's way
but
smaller and it's usually ice.
your assertion, so your first assertion was the vacuum of space will have no effect on the oxygen. Do I even understand how things move through a vacuum? And then I brought up a
There's
comet
no
because I
vacuum.
said,
It's just
"Hey,
zero.
buddy,
There's no
do you
vacuum.
understand that a comet moving through a vacuum leaves a tail?" And your assertion was nothing moving through a vacuum leaves a tail because a vacuum has no effect, and anything moving through a vacuum
There is
would
no
not leave a
vacuum.
tail. There is
If
no
it has
vacuum.
gravity,
100%
yes. If you
agreement.
have something attaching to
Na-
it, and yes, if it is
no,
moving at the
nature
same
abhors.
speed, yeah. But if it's
Nature
moving at the
abhors a
same speed,
vacuum.
it doesn't matter.
Same speed. Oh, you mean so like the Earth traveling at the same speed? Or do you only mean a comet traveling at the same speed?
All
I'm
right, you
saying
have to
if you
ask one
melt
question
off
at a
the
time. You cannot.
substance, yeah, I can address that question. If a comet goes in front of the sun, which is usually when it starts melting and you start getting this trail and you can see it in the sky, if that vapor trail still kept the same speed as the comet, you're right, it wouldn't leave a trail. It's not because it's being pushed by the vacuum or anything. It's not some weird effect where it's
I
moving
just
away
slow
from the
down.
vacuum and it's being disturbed. But it is because it's changing in density, it's moving in all different ways, and it changes the relative speed from the comet to the vapor trail, and then you get a trail, and it glows.
Do you agree that we see comets at nighttime?
We can see a comet, uh,
Yeah, if they're
but you
burning,
won't have
yes.
the same reflective trail. You won't have the same, but you can still see a big trail on a comet during nighttime. But that is pretty obvious as to why. The sun would be in a position where
Okay,
it
but
doesn't make
why,
it
why I
daytime for
asked
you,
that
but you
is,
can see it reflect.
but your assertion was comets only start to produce a tail once they're traveling near the sun, and we see comets at
Yeah, when
nighttime.
they're getting hit by
Generally,
yeah, yes. But that's but that's
so
like
therefore,
asking
that's
why
not
can we
traveling near the sun.
no. That's like asking why can we see the moon at night? because the sun is obviously still there. It's just we're tilted away from it because the Earth rotates. So that's why the sun
or
can
your
light up the
assertion
moon,
is
and it can also light up the
the
comet.
moon, or your assertion is that the moon is only shining because it's near the sun. But we see the moon
No,
on the night side of the Earth, which is not near the sun. You understand, like if you take a sphere and half the sphere is facing towards the sun, and the other half of the sphere is facing toward the
hold on. You're
nighttime.
misrepresenting my
And
argument.
when we
You're
see a
debating a
comet,
straw man.
when we see a comet in the night sky, and it's a tiny pinprick with a little tail, that is not near the sun. In fact, that's
Listen,
180
what do
degrees
you think I
antipodal
mean?
to the sun and probably several light years away from the
What do
sun.
you think
So
I
your
mean by near
presupposition
the sun?
that
So you have to let him talk, because you're asking 20,000 different stupid things, and you can only answer one thing at the same time.
I'm trying to
Yeah,
make a
and also
singular
you're
point.
debating a
Oh,
straw man.
And if you
Can I
don't
please
want to
explain?
understand the singular point
Yeah, but you're
of
debating a straw man
nighttime
because
being
you can't
opposite
just say,
direction to the sun, as opposed to no, comets only create a
okay,
tail.
hold on.
I know it's your
Let
story.
me just
he
I
interject.
know
doesn't
it's
say
what you were
only. He
told.
doesn't say
I know
only. He
it was
just
what we were all told is that comets only produce a
Yes,
tail
but
when it
you
approaches the
started
sun.
this
But
whole
when we
talk.
see a comet, wait, I'm not
you're
finished
still
the
talking
point.
about one thing that's
So
not true.
a singular, you don't see comets at nighttime. You think that's not true. Do you
No, no,
understand
listen, you
nighttime
started
facing
out
away from
saying
the sun?
that I said that we can see the moon at night because it's close to the Earth. You said that I said that, and then you wouldn't stop talking when I tried to correct you. So you debated a straw man this whole time, by the way. I never
That's
said the moon lights
incorrect.
up because it's.
No, you made the false assumption that I would assert that we see the sun, we see the moon only because of the whole analogy with the comets. And then I try to point out that if you're saying the comet only creates a tail because it's near the sun,
Yeah, I
therefore
understand.
you
I
would
remember.
assert
I
that
remember.
the moon only is illuminated because it's near the sun. And it's
But do you
not
remember why I
only
said
because
that?
it's near the sun.
Okay, thank you for clarifying. The reason I said that is because you said you asked if we could see a comet during the night, where it wouldn't really matter if it's like why would that determine if it's close or not to the you obviously know that when I say a comet is
You know
close
what
to the sun,
180
I
degrees?
mean
Why do you
close
think I
enough
made
to
that
melt
point?
the comet.
Okay, so if we saw the comet in the day and we saw the sun in the sky, we saw the comet like 5 or 10 degrees from the sun, I would agree with you that maybe the comet's tail is only caused because it's in close proximity to the sun. What I
Why would it
tried to
matter?
explain, which you decided not to understand, is that on a spherical Earth, half of the sphere is facing towards the sun, the other half of the sphere is facing towards the blackness of space that points outwards. And when we see a comet in our night sky, we're on the side of the sphere that's facing away from the fucking sun. And therefore, that comet showing a tail is not in close proximity to the sun, like you asserted. Now, you
It
can
is
continue to say, no,
way close
I'm
enough to
making
melt
no,
ice. Do you
Can I
understand
ask
that?
someone?
on
That
the,
being
on
in
the
the
opposite side of
Goldilocks
the
zone
earth.
of the Earth,
So,
yeah, if it's yeah,
so
but it's in the
Antarctica
dark.
melts.
I understand what you're saying.
So,
It doesn't matter.
no,
That's
but
close enough.
so
Yes.
Antarctica has no ice because it's close enough to the sun to melt the ice.
Can I ask a
And the North
question?
Pole has no ice because it's
Yeah,
close enough to the
but do you
sun to melt
understand
the
how
ice.
small it is?
When
It
we're in between,
sublimates. It is a
no, but we're in
small ice
between,
rock in space with no gravity, and it sublimates into a vapor trail when it gets into the right spot. You could look up what a comet
but we're
is.
in
It is
between.
very well
But you
explained.
understand that we're in between that zone. So you're saying a comet that I can see at several million miles further away from the sun than we are, we still have ice present. But the comet that's several million miles further than the Earth, it's in a zone that melts the ice, but the Earth's not in a zone that melts the ice. That's
Can I ask
retarded,
a
dude.
question?
Yes,
You
because it has no gravity and it sublimates away.
gravity
Do you know
doesn't
what
control
sublimation is?
temperature. Do you understand why seasons exist? Because they say the
Do you know
angle
what?
of the
Okay,
light that
what
hits
happens
the
when
earth.
you put ice in a
So,
vacuum? What happens
so
when you
when
put
they
ice
say,
in a vacuum? That's very cool.
when they say that seasons are caused by the angle of light, do they mention gravity at all in terms of why we have summer and winter on the Earth?
No.
Before
No,
you
they
guys
don't.
run down this,
They don't mention
before you guys run
gravity
down
at
this
all
rabbit trail, can I ask
because
Solar a
No,
question?
gravity doesn't matter.
gravitational effect has zero effect on the light that's hitting the object.
Solar,
But
you
yeah,
have to
go
give
ahead,
room
ask
to
the
answer
question.
because you're just rambling now.
Can I ask a question?
No,
I've been trying to get
I'm
in for a minute
reinforcing
now.
the point when I'm winning the point,
No,
and the
but you're not
person who
Yeah,
winning the
no,
doesn't
you're
point.
like
not
You're saying
the
1,200
loss
the
different
of the
point.
points.
No, you don't need
is the one
gravity
who
for
wants to
season.
go
You're right. You don't need
the
gravity
point.
for seasons.
You don't need gravity for heat and cold either,
You don't need
and therefore your
gravitational
assertion
change.
because a comet has less gravity, therefore it's losing its ice to
Yes,
evaporation
it can
is
sublimate
retarded
away a lot
because
easier. It's
gravity
not.
has never been asserted as a reason that ice does not melt. That's only your
No,
opinion, brother.
because sublimation isn't melting. Do you know what sublimation is?
Is there any
Of
chance
course
I
I
could
do.
ask a question?
Yeah,
That's so
can you
long.
answer
Go
that
ahead.
though? Do you know what sublimate? Explain
Hold on,
sublimation real quick. The guy who
hold
said
on.
the melting thing.
Go
Before
ahead.
you get
Ask
there,
your point.
Solar, do you, in your understanding, are the tails of comets always pointing retrograde?
In our observations, yes, the tail tends to point away from the sun. Yes.
Away from the sun or retrograde? Those are not the same thing.
Well, retrograde means moving backwards or directed away. So it is kind of the same thing.
No, retrograde it means in the exact opposite direction of your summed vectors. I.e., if I'm moving
Yes,
down a road,
toward
if I'm
moving
moving down a
backwards or
road from
directed.
east to west, east would be retrograde for me. So I'm going to ask you again. Are comets' tails retrograde, meaning they're stringing out behind them, or are they pointing away from the sun?
I would say that I've seen demonstrations or examples of both. I've seen tails that point laterally so that we can actually observe the tail. Or if it's in our night sky, we shouldn't actually see the tail because it should be pointed away from the sun, which is behind us. So I've visually seen both options. And like I said, retrograde, the definition from Oxford Dictionary is directed or moving backward. And backward is quite ambiguous. So
No,
it's
it's antipodal to the summed vector of travel. That's I don't know how to make it any simpler than that.
perhaps, but you got to presuppose a direction of travel because that same comet is moving east to west in our night sky. And you can presuppose that while it's moving east to west, it's also got some other vector, but that's not proven. So you can go ahead
You
on
guys
your
also realize
presupposition.
I
we
don't
only
even
ended up on this argument, by the way, because I was being argued against on how the atmosphere would just like fly away if we're going a certain amount of speed through the vacuum of space. Because a comet has a tail and therefore Earth doesn't. So I like how we got very sidetracked away on this particular point on the angle of a comet tail when we were discussing atmospheric contention and why oxygen wouldn't escape. So we
right.
got very
Um,
sidetracked.
let me draw the link for you. I apologize. If the comet's tails are not retrograde, but rather blown away by the cosmic winds from the sun, then something traveling through the vacuum of space wouldn't inherently leave a cloud behind it. Although the Earth does, because we're losing so much air every day.
Oh, so the Earth does have a tail. Okay. Well, the previous guy was asserting that it doesn't, and that the oxygen simply stays perfectly lockstep with this rocky ball that's moving at 66,000 miles per hour around the sun and not generating a tail or
But
losing any oxygen.
you understand that the speed you're mentioning doesn't do anything, because everything is traveling at the same speed. So there's no, I don't even know why you mention speed.
Again, presupposition. So talking about
Big numbers,
cosmic
Terry.
winds. So you think the Earth does not pass through the cosmic winds in its orbital trajectory around the sun? Or does it?
Does the Earth rotate through the cosmic winds?
So, in my understanding, and please correct me if
My
I'm wrong,
question to you is,
most of the solar winds come from the sun, or most of the local solar winds anyway, come from the sun and radiate out from that in a myriad of patterns depending on solar activity and cycles and things like that. And they go out radially in all directions.
Yes.
We see this here on Earth
the
when there's
cosmic
a
winds.
solar.
We lose about 90 tons a day, which is very little.
Right.
And what do you think a comet loses a day? Very little. But yet it's a visible tail.
Depends on the size
You
of
think
the
it's
comet.
more than 90 tons or less than 90 tons from a
Depends on the
comet? Yeah, it would
Depends on
depend
how
on the
big it
size
is.
of the comet.
Right.
And like you already said, the comets are so small and therefore their gravitational strength is so low.
There
I
are
think that
small
they're
ones, there are
losing
big ones.
less or more than 90 tons a day.
It's like
Depends on how big it
asking,
is, right?
it's like asking, are there more than a million birds above my house, or less than a million? I don't know.
No, that's a retarded straw man.
No,
Of course,
that's what you're using.
Of course, a tiny comet is going to be losing less than 90 tons a day. Like, are you guys this fucking thick? Like, it really doesn't take
You're making numbers
decent
up.
faculty of thinking. No, you guys gave me the 90 tons a day, not me. I didn't make up anything.
Sure.
We're talking about small little comets, small, tiny little comets that leave tails
So let's say
because they're
let's say
sublimating intergalactic state.
let's say the rock is 80 tons. How can it lose 90 tons?
Exactly. So what answer would you give me if I asked you, are they losing 90 tons a day? Less
Well,
or
you're
more
making
than
up
the
random
Earth?
numbers, so I don't know.
No. Your example was the object only weighs 80 tons. Do you think it's losing 90 tons a day if the object only weighs 80 tons?
That would not be possible.
Yes or no? This is not higher grade. It's not advanced physics.
if the chemistry, if the
No,
if
not
everything-
accept. It's a yes or a no. Do you think the object can lose more than its
Well,
entire mass
well,
every
technically,
day?
there's a possibility. It's the same as a paper weighs only 5 grams, but if you light it, it weighs 5.2 grams or something, because after burning, it becomes heavier. So there is a.
And then the next day, can it lose another 5 grams? And then the next day, lose another
Because
5 grams?
because it's already burned.
You're just obfuscating from the really obvious answer. Can it lose more than the Earth loses a day?
But
Your
again,
guy's entire assertion
you're
was
arguing something
the
that's
comet
irrelevant.
is losing more than the Earth.
So I have
which
an
is
answer for you.
false.
I just was able to find this white paper, and according to this, it loses about 1 kilogram per second, which it would be much less than the 90 tons. However, due to the mass of this particular comet, it is a larger percentage of its mass.
Yeah, exactly. So the larger the comet, the more you lose.
Oh.
That's all right.
I posted the wrong link. I apologize. Here's the correct link.
And it
I
also
don't know
says the
why.
scale
Alright.
of loss can be.
Anyone want to be intellectually honest and actually answer the question? Does the Earth lose more, or does the comet lose more per day?
The
The
comet
leaves
loses
a
more.
visible tail.
It can
No, that's
lose
false.
tons per second. No, that is not true. It can lose tons per second.
He said a
It's,
kilogram. Perhaps you need to unblock your ears.
That's wrong.
He said a
A comet
kilogram
can
a
lose.
second.
That's wrong. It
36,000
can be
seconds.
tons per second.
It can lose 3.6 tons per day, and the Earth is losing 90 tons. Which one do you think is more? 90
Do you
or
under
3.6?
which one do you think makes gases that sublimate stick to it a lot more? And which ones do you think have a way larger surface
Yeah,
area?
that's true.
So
Sublimated
the
gases
trail would
don't.
be way more spread out. If you have a bigger surface area, whatever trail you create from your atmospheric loss is going to be way more faded out if you have a huge ass Earth, obviously, as well. But now you also have gravity making it stick. But some comets can lose tons of material per second through ionization and
Oh, so
loss.
they're bigger than the Earth. So they're bigger than the Earth then.
No,
It
If
doesn't
the
matter.
Earth's
it's
It's
not.
only losing
how
No,
much
90
you
because
tons
lose.
it
a
doesn't
day,
stick to it in this
Yeah, yeah.
in the same way.
no gases stick. I don't know if this is new to you or like maybe it's a completely unknown
What do you
concept,
mean no
but no
gases stick?
gases stick.
Hey, Solar, if you
No,
if you
it's
if you ha-
can't say this any
if you
small
leave a fart in your
No
pants and you walk
gases
by,
stick.
I can smell it
Gases are
after you walk by.
unbound molecules moving in all directions. Gases are unbound molecules moving in
No,
all directions. So
No.
yes,
gases
gravity
do
affects
not
them.
stick unless they are
Gravity
contained.
affects them.
That's false, as we asserted with
How is that false?
the
That's how we
gases
have
at
a
ground
pressure on the
level.
ground.
Gases at ground level move in all directions. Therefore,
They
gravity
flow.
at ground level
They
does
also all
not
move down somehow.
contain gas. No, they don't. The only time a gas molecule moves downward is through a collision, and then it has another collision and moves in any direction it chooses. So there is not a predetermined downward vector of gases the way that you're
That is not
trying to
true.
impose them.
It always have a default down.
You
And then
think,
you can
you
fill a
think they
container
have a
any
default
direction
down.
you want. Just because you can fill a
Please
container with
cite
a hole
that.
in the bottom and it shoots up doesn't mean it doesn't have the same. We know that gas is being pulled towards the Earth.
Please cite that opinion because that's only your opinion. Gases do
I
not
don't think
have a
that's only
predetermined
my
down.
opinion.
Gases move in all directions to fill the available volume. Always.
Would you?
That's a law.
Would
Because
you?
because there's a pressure created on the gas. Guess why? Because it's all being smushed into each other because of gravity. So now it has to displace in any way that it can if an empty space is available to it. The only
Yeah,
reason it has
Solar,
the pressure to do that to
you
begin
cannot
with
use
is because it's being
scientific rules
accelerated downwards.
and then deny half the rule.
He
What do
said
you
a predetermined vector downward and then goes on a ramble about how they'll move in all directions and how they
That's why
squish
they move in all
downwards.
directions. That's why they move in all directions.
No, they just randomly move in all
No,
directions. There is no
because
vector
they
to a gas
are
molecule.
being pushed together
It's not random.
by a downward force. They are being smushed, and that's why they're being pressurized. And because they're
Being
pressurized, they
smushed.
will shoot out in all
Your opinion,
directions.
bro.
I think we've got
What do you
two
think
things
is
going on
mushing
here,
it
right?
together?
Always.
Seriously, what do you think is mushing the air
They
to
will-
make it pressurized on atmospheric level? What do you think is mushing it?
Containment.
If it's not
Containment, obviously. Because to have gas pressure in the first place requires a container. That's obvious. And I know you don't agree, but it is obvious.
now you would
It is
require
obvious.
your dome. You would
In the
have to have a
definition.
dome over there, and you would have to pressurize it from the outside until it's like pressurized a lot on the inside. So if you have a dome and you make a little hole in this dome, it's all just going to shoot out.
Until there's a gradiated pressure. Until there's a gradiated pressure. But yes, to have
Why
pressure
would
in the
it be
first place
gradiated?
requires containment.
But why would it be gradiated?
Because of the scale. Because of the scale.
Because
This
of
is
gravity.
I write
you can
that
have
in the
pressure
chat.
without a container argument. I've seen it so many times. It's so tiring. Ugh.
It's because the definition of pressure is the pressing on the walls of its container. That's not our definition. It is the fucking definition. So,
What causes
so
that?
tiring.
What causes that?
Yeah, and then you can go one step further and ask, why is it doing that?
Yeah, but he doesn't want to ask why. He just want
Because
to
it's
quote whatever
contained.
fits.
Yeah, he gets stuck in step A instead of step B.
It's baby step 1 is he knows, and then baby step 2 he doesn't know.
Yeah.
You cannot have a delta of the pressure or a variation of the pressure
The whole
without
containment
having the
argument
pressure in
doesn't
the
doesn't
first place.
doesn't make sense.
So
It does
if
make sense, and it's a law.
No.
So you can choose
Yeah, it's
to
a law, but
completely
you're
disregard the
denying the
law.
other half.
You can live in
Hold
your
on.
imagination.
Yeah,
No
that's what you're
demonstration of
doing.
gas pressure without containment.
Wow. Okay.
Can you
Okay.
give me 4
Wow.
atmospheres of pressure, but I just want it in a bowl?
Wow.
I don't want it in a container. Just
Yeah. Wow.
present
Wow.
for me 4 atmospheres of pressure,
So
but I'd
you
like
quote
it to
you quote science when
remain
it
in a
fits you,
bowl.
and you deny science when it doesn't fit you. That's what's going on here.
Solar, do you remember in
Definitions
2000?
are science, bro.
Do you remember the eruption in Iceland in 2010?
I
The
heard about it.
volcanic eruption.
I remember the dust cloud.
Yeah, there was a volcanic
Do
eruption in
you
Iceland.
understand that the pressure built up? But you understand that the pressure built up because the gas was contained under the earth or inside of the volcano
Wow.
until that
Hold on.
containment broke. And once the containment broke, it equilibrated. Do you understand
And do you
that
see how
point?
the
Or is that
lava
also
just
lost
fell
on you?
down to the ground afterwards as well? How it just fell
Hold
down
on a
again
second.
after
We're
it burst?
talking about gas. Hey, buddy, try
I
keep up.
know,
We're
but
talking
like,
about gases, not
I know. I
lava.
just had to make that comment. I'm sorry.
Lava is a liquid, and liquids behave very differently to gases. We're talking about the gas pressure that
Right.
can only exist when contained, because
Gases
when
flow,
that
just
containment
like
is
liquids.
no longer
Okay,
evident, it
I would like to get to the
equilibrates.
second half of my point when you're ready. Okay. So
I'm
after
ready. I'm just responding to the moron who was talking about fucking lava.
Just lower the autism a little bit so we can answer. Oh my god.
after the eruption, the Icelandic government had to evacuate a town. They had to do that because this town sat in a valley that and there was a sulfur hexafluoride found running down that valley, and they had to get all the people out so they didn't die. Why did they have to move those people if gas, such as sulfur hexafluoride, moves in all directions?
Because sulfur hexafluoride is slightly more dense than air, and therefore
Whoa.
it would form
It has
gaseous layer,
it has a,
but
it
it's
has a
not
molecular weight.
contained. It's not contained. So the surface of that sulfur hexafluoride is constantly leaching into the normal atmospheric layer, but the majority of it stays down because it's slightly more dense. And therefore, dense gases will sink, and less dense gases like hydrogen and helium will move upward. And therefore, it's a
Okay.
density relationship and not a gravitational relationship. But thanks for the story. It's a
Okay. So
great analogy.
If that were the case, and let's just accept that's the case for the moment. Why did that sulfur hexafluoride eventually dissipate and allow the people to move back into the city? If it is truly density, because it is such a dense gas, wouldn't it have just stayed there forever?
Did you not hear my response that the exterior of that gas would be constantly leaching into the other layer, and therefore it is not contained, which is
But
my entire point. And if it were contained, it would remain there indefinitely, but it was not contained. And therefore,
so
gases will eventually heat up and blend with the atmospheric layer, and therefore will
okay,
continue to move in all directions as it becomes diluted and less dense. And therefore, because it's not contained, it would not remain there indefinitely, which is my entire argument that the
okay.
only way to keep gas pressure there is to contain it.
So can you? I'm confused about your definition of a container because the valley was enough of a container for the sulfur hexafluoride to settle down and require all the people to be moved. But now you're saying it's not enough of a container. Can you please be more
An
definitive
open
about the
container
definition?
versus a closed open container or closed container. You understand the difference? So
no.
if I take a cup, that's an open container. If I
No.
take a sealed box, an airtight box, that is a closed container. A closed container will contain the gas indefinitely. An open container having a singular side or in a valley, almost 50% of the open surface is in contact with another gaseous medium. Therefore, the gas will continue to leach on the open side. When I
Okay.
talk about containment
Hold on. You
containing
made
the
a point.
gas,
You gotta let me
when we
respond.
talk about a volcano, when we talk about a volcano
work on it.
containing
Jesus
the
Christ.
gas, it is a closed container until the top of the volcano blows off. Then it
Can you
becomes an
can you say container 12
open
more times, please?
container. When it's an
Hold on.
open container,
Oh my god.
it will blend. When it's a closed container, it will contain. Do you understand the difference between an open and a closed container? Is this
So
really that
no,
far of a
you
higher
ask
grade
questions. I'm
point
still not allowed to
that you
speak.
don't understand the difference?
Yeah, he's just going
Your
on, right?
question was, why would it not stay in the valley indefinitely? Are you this thick that you don't understand that a valley is not a closed container?
You don't understand the difference between the density of the gases.
Right. If it's a density relationship that
Yeah.
causes the sulfur hexafluoride to fall down, then the density relationship would remain and that valley would
Yeah.
still be uninhabitable. As it
Exactly.
is, it's not. You can go there.
Yeah. And he
It's an
says it leaches
open.
out, but it leaches out is a non-existent argument. It doesn't leach out.
Of course it does. It blends. In the same way that if I take a slightly denser liquid and then I
Yeah,
start mixing a
can you put
less dense liquid into
can you put
the
oil on top of
more
water
dense liquid,
and make a
what
blend
happens?
by
What
waiting?
happens if I mix dense with more dense? What happens?
Please
Do they
blend water
mix,
and oil,
or
please.
does it constantly remain in the two separate states?
Yeah.
Well, I'd say it was a question. There was a question mark behind that. What happens if I mix less dense liquid with more dense liquid? Do they remain as a more dense liquid and a less dense liquid? Or
Depends.
do they mix?
You cannot
depends.
mix.
Depends on what.
It depends on what your mixing
You
method. It depends
you
on
can't
what.
mix more
I'm sorry.
more
I'm sorry.
dense
I
liquid
thought
with
you.
Asked me a question and then asked me to continue my explanation when I only gave you the two answers. If you only want the two words, just say so and I'll go ahead and back out now.
No, someone else was trying to assert that less dense never mixes with more dense, which is moronic.
Okay. So it depends on all the forces and the time involved. You can get things, you can emulsify a liquid in order to get it to mix for a short time, but it will resort itself out to all forces acting on the liquid.
Yeah.
This is why on Navy ships, we float the fuel on top of the water. Even though when we first pour it in, it emulsifies and mixes and is unusable, all the major naval shipping around the world is using water-filled tanks, and only the top part is the fuel.
Gordon, what's this got to do with
Yes,
floaters?
because fuel is oil based and water is water based. So therefore they will not mix.
Because of
This is not higher grade.
density.
Oil based and water based will never mix regardless of
Density-wise.
density.
They separate because of density, but they don't mix because of their chemistry and physical properties.
Their physical
Right,
properties will not allow
when
them
you're
to
pouring
mix.
it into when you're pouring the fuel into a tank that has a little bit in there, it will emulsify and mix.
No, it will create little
Tank.
oil
That's a good
bubbles
word to use.
that will
Tank.
eventually
It's like a
settle on the
container.
surface. The fact that you're trying to argue this just shows that you have no idea what you're talking about.
Yeah, you're right. I've never even been on a boat. How'd you figure it out, Solar? Wow.
I'm not talking about being on a boat, you moron. I'm talking about an oil-based substance never mixing with a water-based substance. So being
I'm
on
sure.
top of a ship does not
I
make
sure
you an
thought that-
expert in the
I
fucking
sure thought we were
chemical
talking about.
properties of oil-based versus water-based.
It only
I
mixes
just thought we
Can
were
you watch
talking
an
when you
about.
enamel?
introduce
Can you wash
energy,
an
and
enamel
when you
paint
remove
off with
energy,
water?
it doesn't mix.
I thought we were talking about the naval vessel that I was just referencing. I apologize if you changed topics and didn't signal the lane change. Go ahead, we'll follow you.
How did I change topics by talking about exactly what you were talking about when you pour an oil-based petroleum on top of a water substance? And as Dazza just elucidated, but you guys wouldn't pick up on his cue, their chemical properties will not allow them to mix. So you can continue to assert that because you stood on top of a ship, that somehow you think oil-based substances and water-based substances should blend in your imagination, although they
Nope.
don't. Regardless,
Solar,
they will
you're right.
never. But
I've
yes,
never been on a ship.
complete
I don't
topic
even.
change because I'm
I don't
talking
even know.
about what you brought up.
You're right. We weren't talking about the naval ship that I brought up. That obviously I've never spent a single night aboard a naval ship. You're completely right, Solar.
You do know that density is a property, right?
Well, I know that Solar's probably better on this next cruise than I am. Should I go ahead and put your name down as captain?
Okay, your inability to understand the point that you brought up is on you, bro. That's on you. That's entirely on you. The fact that you don't understand petroleum and water solutions don't mix, when you brought it up on the ship that you claim that you were on, that's on
I
you,
said
bro.
I'm never on it.
Enjoy it.
You're right. I was never on
You're,
it. You told
you're
me I wasn't on it, so I must have never
I
been on it.
never said you weren't on it. I never said you weren't on it. Only you've said you weren't on it. You
Okay,
brought up petroleum
you're
But
completely
the
right.
problem
poured
is
into the fuel tank
that all the
on
gases
top
can
of
mix.
Oh
water.
God,
If you
can
introduce
we
some,
move forward?
So,
I don't know.
I don't know. Can we move forward? Because
Probably
Drink of
not.
Kool-Aid seems to be trying to create a straw man that I say he's never been on a boat, where I never once said that.
Mhm.
Simply
Why
pointed
did
out
the two different
singular point.
densities mix? I mean, why does the heavier one go to the bottom though?
Oh, did you missed it, Left Lane? They don't mix. Solar's just told us emulsification does not happen.
yeah,
Oh,
Emulsification is not blending when it's an oil-based and a water-based substance. This is like this is third grade science. You pour oil on top of water and the oil sits on top of the water. Initially, it can have little oil bubbles or little oil balls that appear to emulsify below. And eventually, after enough time, they will settle back into the oil layer above the water.
yeah. Good job. You pay attention sometimes.
yeah. I'm just wondering why the more dense fluid is on the bottom.
Because it's heavier.
I agree with that.
And liquids behave very differently to gases. Do you also agree with that?
No, I
And
would
therefore,
say I would tend to say
steel.
they're more like than different in the way of fluids, the way fluids act.
The
Right.
difference is that a gas can compress and the fluids cannot compress.
Yes.
But physics is still
And
physics, and you still
less
need.
dense and more dense gases will blend eventually. That's why your sulfur hexafluoride, after so many hours, will no longer be in the fish tank or the valley or any kind of open container, because gases will mix in terms of high density and low density, whereas liquids, when you have different liquids in a closed container like a fuel tank, will never mix. Was the point of the entire fucking discussion